Miss McKnight and Mr. Maya's class. Hello, good morning, class. What a wonderful day, and welcome to Miss McKnight and Mr. Maya's class. Super fun day. Today, we're going to be talking about the, the properties of special parallelograms. So, as you guys can recall, in the past, we talked about parallelograms. But this time, we're going to talk about the special ones. Okay. All right. So, your essential question: what are the properties of rectangles, rhombi, and squares, and how do I solve problems involving them? All right. So, and as you can guess, rectangles, rhombi, and squares. Rhombi is the plural form of rhombus. Those are special parallelograms, and we're going to talk about those. All right. So let's go ahead and start talking about these. Okay. So, what are the properties of rectangles? So, they share the same properties of parallelograms. Okay. So, for example, we will have, what do you call it? We have the opposite sides are congruent. So that's for sure. Opposite angles.
Mr. Maya,
Uh-huh.
I don't see your screen, so I'm not sure if you're sharing your screen or not.
Oh, thank you.
No
Yeah, I forgot to click share.
problem.
Silly me. All right, can you guys see it now? All right.
Yeah.
Yeah.
All right, thank you. All right. So what are the properties of parallelograms? Excuse me, the properties. The first ones, we'll remember the opposite sides are congruent. Opposite sides are parallel. Then we also have opposite angles are congruent. Okay. Then consecutive angles are supplementary. Diagonals bisect each other plus these. So we have keep those in mind, and we have two more. Okay, the first one is that all four angles measure 90 degrees. Okay, that is essential to remember. And we have the diagonals are congruent. Congruent. All right. So let's go ahead and do some examples. Let's start off with this first one. Okay. Number one. Each quadrilateral below is a rectangle. Find the missing measures. So let's see. They ask us for QR. Well, we know that a rectangle is a parallelogram. Okay, so QR and PS, those are opposite sides, and therefore they are congruent. So QR is 10, just like PS. Remember, prior knowledge. Okay, prior knowledge. We're not allowed to, you guys are not allowed to forget what you've learned prior to this. Then SR. SR is going to be, well, we see that SR is opposite of PQ. And if PQ is 24, SR is therefore also 24. Okay. SQ. Where's SQ? Right here. Okay. What is the length of SQ? Well, we know that it's 26 because if from S to T, that's 13. T is the midpoint. Remember, the diagonals bisect each other. So T is the midpoint, meaning that QT is congruent to ST. And if they're both 13, together they are 26. Okay. Then we're being asked for PR. Well, PR is the other diagonal. Ooh, well, they don't give us a measure here. And they also don't give us a measure here. But we have this property. Remember, diagonals are congruent. This number 2 right here. Yes, Christopher put is also 26. Yes, very smart. Yes, you went ahead and you kept this in mind. But diagonals are congruent. So if SQ is 26, PR is also 26. What about QT? Well, we determined that as we were doing SQ, we determined that it's also 13. Okay. Simple enough. So now I'm going to let you guys give this one a try. How about number 2? So I don't think it should take too long. So I'm going to go ahead and have you guys answer along. So somebody give me, what is AC?
AC is 30 because you do 15 times 2.
Very good. AC, yeah, because they tell us AE is 15. Therefore, CE is also 15. Put them together, you get 30. Oh, that 3 looks not so nice. There we go. What about BD? Where's BD? Oh, over here. Christopher says it's 30. Well, again, diagonals are congruent. If AC is 30, BD is also 30. All right. What about BE? So yes, good job, Christopher. Oh, who answered AC? Was that Graham? Where you went with? I didn't notice who's. Okay, very good. Virtual high five and virtual high five for Christopher. Okay, Hannah, I can see that you want to say something. Do you want to go? Are you going to try and answer BE?
Okay. For BE, honestly, I'm still kind of confused on these, so.
Okay, that's okay. It's okay to be confused. It wouldn't be mathematics if we're confusing. So let's remember our properties. In fact, let's remember this one right here. I think that this is one that they're all important. But this one right now, focus on this one, on the second one that's special to rectangles.
Okay.
So diagonals are congruent, and so that one and this one right here, diagonals bisect each other. So let's go ahead and think about it. So what can you tell me? So we've determined that AC is 30 because A to E, that's 15. Therefore, C to E is also 15. Put them together, you get 30. So what can you tell me about diagonal DB?
You mean BE?
DE. So tell me, what can you, about DB from D to B? Right here, all of this?
It will also be 30.
It would also be 30. So what can you tell me about just this part? If if the diagonals are bisected, if E is the midpoint, what can you tell me about that segment that's in blue?
Would it also be 15
It would
since
be,
BD is 30?
yeah, it would be 15. So BE is 15. And what about, it doesn't ask us, but what about DE? This red segment that I just traced.
It will also be 15.
It would all, yeah, very good. So when you guys, with rectangles, there you go. Now it asks us for AB. What is AB from A? This distance right here, this length.
AB would be 27 because above it says opposite sides are congruent.
Very good. If AB and DC are opposite sides, therefore they're congruent. And if DC is 27, AB is also 27. Very good. You guys are on fire. So you guys are going to have to stop, drop, and roll. All right. What about BC?
$13.1.
Very good. 13.1. Yeah, because BC is opposite of AD. And if AD is 13.1, BC is 13.1. Okay. Seems easy, right? Well, we're not going to, oh no, yeah, we're going to do these ones because now we're going to talk about angles. Well, let's go ahead and scroll a little bit down right here. All right. So now they ask us, and let's switch things up. Let's use blue pen now. I like blue. So what about the measurement of angle MJK? MJK, where's MJK? MJK. Okay, this angle right here. What does that measure?
I'm assuming that's 90 degrees
Why do you assume that's 90 degrees?
because it looks like a right angle.
So don't go off of what it looks like, but always remember, you are correct, but remember what it says right here?
Oh,
So you are correct. I just don't like that you guys made that mistake that could really hurt you. Okay, making an assumption, be like, oh, it looks like a right angle. So it is a right angle, but all four angles measure 90 degrees. Okay, so remember that property. All right, but you are correct. It is 90. So MJK 90 degrees. All right. Now what about the measurement of angle MJL? Where's MJL? MJL, that's this one right here. What would that be? Oh, James, you just joined us. James, there's a note template on Google Classroom. It's the one that's the properties of special parallelograms. Okay. And right now we're working on rectangles. Right, so what does this angle measure right here? Just this one right here. Michael, 90. So if this is a rectangle, this was told to us like earlier in the instructions, said that these are rectangles. And if these are rectangles, remember this property says all four angles measure 90 degrees. So that means that MJK, this entire angle right here is 90 degrees. Now let's see how. This one MJK, let's find MJL. MJL is just this one right here.
wouldn't you just subtract 27 from 90 degrees?
Very good. Yes, Christopher got it. It's 63. 90 minus 27. 90 minus 27. 63 degrees. Very good. And Nicole, very good. Yeah, 63. Okay. Well, Nicole, you're asking. You don't ask. You got to say it with confidence. 63. 63 degrees. 63 degrees. Okay. All right. So now, measurement of angle JLK. Where's JLK? JLK. That's this angle right here. That's this one right here. Well, you guys remember how parallelograms, you guys deal with alternate interior angles because you have, because you have opposite sides, which are parallel lines, and then you have, right here, that's an opposite, these are parallel lines, and then you have this transversal. So that would mean that this angle right here and this one are alternate interior angles. So JLK and MJL are alternate interior angles. And we determined that this one is 63 That's an ugly 3, but you guys get what I'm doing. If that one is 63, that means that angle JLK is also 63 degrees. All right. JLK is also 63 degrees. Now let's go ahead and do angle KML. KML, where's KML? And in fact, you know what also helps right here? If you guys kind of like start, when you guys are doing this, remember when you guys dealt with isosceles triangles and the base angles theorem? Yeah, that still applies. Like, oh, we could forget about that. No, you're not allowed to forget. So here's the thing. We determined that this angle and this angle are congruent. Okay. Now, these diagonals, remember how we also realized that all diagonals in a, excuse me, this is the case. So if that's the case, you guys see these markings? So that means that these triangles that are formed inside the rectangle because of the diagonals are all isosceles triangles. So what does that mean? That means that this angle is congruent to this one, and that this angle is congruent to this one, and that this one is congruent to this. This one is congruent to this. This one is congruent to this. This one is congruent to that. In fact, let's do that again, but I'm gonna use a different color. All right. I'm gonna use that. I'm gonna use orange to mark these. And I'm gonna use blue. So that tells us that these angles are all congruent. And let's use red for this. This angle is congruent to this one. And as well as this one right here. So that means that all those angles that I marked with two curves, or in other words in red, are 27 degrees. All the blue ones are, all the blue angles or the blue curves, those are 63. So let's go ahead and see what's the measurement of angle KML. Let's go back to using the blue mark, the blue pen. KML, where's K? Where's M? And there's L. So this one right here, this angle, how much does that measure? 27 degrees, okay? And the last one it asks for is angle MNL. MNL is MNL, this one right here. How much does that measure? Ooh. You guys remember that number 6 when you guys are like, oh, what's the catch on that other lecture the other day? What was the thing that I brought back that so many of you guys were overlooking? What's the measurement of this angle right here? How do we find it? Prior knowledge. So we know what these two angles measure. So if we have two angles of a triangle and we need to find that third one, how do we do it? You guys are making Miss McKnight and I cry. Well, you're going to take 180 because remember, in the triangle, you have 180 degrees. And you're going to subtract the sum of the other two angles that you do have. And these red ones are 27. They're each 27. So you can just do 27 times 2. So this becomes 180 minus 27 times 2. That's 56. So 180 minus 56 equals 124. So 124 degrees is the measurement of angle MNL. Okay, now you guys are going to try number 4 on your own. You guys can do it. A little challenging, but it's just a matter of putting it all together. Are you guys scared because I brought back the isosceles triangle and the base angles? If that scares you, then that scares me too. I'm going to be scared if you guys are scared. Okay. So I'll give you guys till 11:11, and then we'll go ahead and start, and we'll go ahead and see what you guys got for that. You guys got a little less than a minute, and we'll go ahead and do this one. All right, it's 11:11. So let's go ahead and do this one. Who would like to go? And you don't have to tell me everything in here. You can just, and you don't have to go in order. If you maybe you can start here, you can start here. It doesn't matter, as long as it's participate. Or am I gonna have to use the random selector? Actually, no. I will choose. Let's see. I'm going to pick student. McKinley. So do you have anything for me? Did you get any of these? Or anybody? Did anybody get anything from here? Are you guys stuck? If you're stuck, tell me. Ashley, you're stuck. Michael, you say you got 64. What is 64? Okay. Michael, what did you get 64 as? Because which angle? XW. You say that this angle right here is 64? Ooh, no. That is not correct. Okay. Ashley, you say you're stuck. Okay. And Nicole, you say you got 58 for this one. Nicole, that one's 58. Okay, let's see if you are correct. Let me see. 58 times 2. Okay, I just did my calculator, and you are correct. How did you get 58? So this would be like you coming to the front of the class. You're gonna tell us how you did it.
Oh, okay. So I got 2x. I did 2x plus 64 equals 180. And then I got 2x equals 116. And then I got x equals 58.
2x. I'm sorry. 2x equals how much?
116.
Okay, and
then x equals 58.
that is correct. Why did you set it like this? Why did you say 2x plus 64 equals 180?
Because of the previous chapters, how we did each triangle.
Okay.
Yeah.
So, but how did you know that this angle and that this angle were congruent?
Because it's a isosceles triangle, right?
Okay, very good. Yes. Yeah. So you are correct. I just wanted to make sure that you were saying it. Hang on. Give me a second. I hear a little bit of a noise, and I think it's on my own computer. No, it's not. Okay. Sorry. I thought I heard. I thought I had a YouTube video playing on my background.
Oh, it's probably my little sister. She's watching.
Oh, okay. Okay, that's okay. I just wanted to make sure it wasn't mine. All right. So that's very good. Well, how about now? So from here, what else can you guys determine? So, and very good, Nicole. That's very good that you remember the prior knowledge. We're not allowed to forget things. All right, Christopher says YXZ. Where's YXZ? YXZ would be 32. Yes, it would be 32. This angle right here, let's use red. This blue angle and this red angle right here, this one that I'm marking with two curves, together they make 90 degrees. So if together they make 90 degrees, and this one's 58, that means that this one has to be 32. YXZ. YXZ. What else can we do? Let's put the degrees on here. So what about, let's say, WVZ? Where's WVZ? Right here. What about this one? Let's use red. Oh, and I'm going to mark these again because you guys, as you remember, those are congruent. Okay, let's use purple. So what about this one right here? What about this angle? WVZ. You guys remember this? I know you guys. You got to
Is
dig
it
it.
116?
How'd you get that?
I multiplied 32 by 2.
Okay.
And then I subtracted that from 180, which equals 116.
Okay, so you did this. Oh, let me use my red pen. So you remembered that this, you did alternate interior angles and you realized that, and then the base angles theorem. So you did this, and you're like, okay, if this is 32, therefore so these two are 32, so 180 minus 64 equals 116. Yeah, so that is correct. But you guys want to know a more, well, I wouldn't say an easier way. To me, it's easier, but let me hide this notification. To me, it's easier, but for you guys, it might not be. But I'm going to tell you how I did it. Right here, we have, let me get my eraser. Let's make that smaller. Okay. Right here, we have a straight line. So what do straight lines, how much do those measure in degrees? 180 degrees. And if this angle is 64, and together they make 180, so you would do 180 minus 64, it gives you 116. These are supplementary angles. Okay, but your way of doing it, Christopher, is also correct. I just think that the way I did it right now may save you some trouble. It's up to you guys. There are many ways to cook a turkey or whatever the saying says. All right, so what about XWZ? XWZ. Well, XWZ is, yeah, 90. Well, how do we know that? Well, because it's the angle of all angles in a rectangle are 90 degrees. So XWZ is 90. What about XZY? XZY is this one right here. So what's this angle right here with the red? What is it? Johnny, you want to say, you want to? Oh, I pointed to the XZY, XZY. No, XZY is this one right here. Yeah, I pointed to this one. It's not that one. It's this one right here. Someone remember what that one measures? In fact, let's remember alternate interior angles. So this one is congruent to this one right here. And because they're isosceles triangles, we also say this. In fact, all the blue angles measure the same. So the X, Z, Y. Does someone remember what does this angle measure right here? This one? 58, yes. All right. So now we're going to talk about rhombi, not rhombuses. They're called rhombi. Okay, so the properties of a rhombi, well, they have the same properties of parallelograms and three more. Okay, so all these that we have, and my red pen, yeah. All four sides are congruent. All four sides are congruent. Diagonals are perpendicular. and diagonals bisect opposite angles. All right. So I'm going to model this first one for you guys. If JK is 12 and JN is 7, well, let's find these. What's JM? JK right here, this one is 12. JM is, well, they may not be opposite sides, but they don't have to be opposite sides. All sides are congruent, all four sides. So if JN, excuse me, if JK is 12, JM is also 12. JN is 7. Where's JN? Right here. If that's 7, that means that NL is 7 or LN 7. Oh, it asks us for JL. Well, this is also 7, the 4, 14. Okay. They say that they ask for MN. What's MN? From here to here. Well, if K to N is 9.7, that means M to N is also 9.7. Remember, the diagonals bisect each other. And then, so you would say, you know, this is congruent to this, and this, and this. Actually, let's make these be 3. 3, 3, 3 right here. 3, 3. Okay. Then we also have this is congruent to this. This is congruent to this. So what about MK? From M to K? Well, if KN is 9.7, now we just multiply that by 2. 9.7 times 2 gives us 19.4. All right, now you guys are going to try number 2 on your own. I'll give you a minute. It shouldn't take you too long. Okay. All right, let's go ahead and get to this. Let's get down to business. What is GF? And don't say it stands for girlfriend. No, talking about this segment right here. What's that length right here? 23. Very good. Oh, you know that all four sides are congruent. Yeah, if EF is 23, GF is 23, DE is 23, DG is 23. What about HF? So Kaylin and Graham, very good. Thank you for that. All right, so you guys are saying 20. HF? Yeah. If from D to F it's 40, that means H to F is 20 because H is the midpoint. So 20. Very good. And Hannah, yes. All right, very good. What about GH? This right here. What's that? 11.4. Very good. Yeah, it's congruent to EH. And what about GE? 22.8. Yes. All right, I'm going to do 3. No, I'm not going to do 3. I'm going to do number 4. I want you guys to do number 5 on your own. 4. Measurement of angle 1. Okay, let's look at this right here. Well, they tell me that this is 38. So I'm going to go ahead and start marking things. I know that this is 30. If this is 38, well, so is this because they're alternate interior angles. So this is congruent to this. But not only, but one more thing. Remember that diagonals bisect opposite angles? So if these angles, so if this entire angle right here is being bisected, that means that they both measure the same. So this is also 38 degrees. So these angles are congruent, and these angles are congruent. Yeah. And I can also say the following. This angle is congruent to this one, and this one is congruent to this one. Why? Because, again, the diagonals are bisecting them. So if this is 38, that means that this entire thing is 76. So if right here we have a total of 76 degrees, I'm going to do this. Opposite angles are congruent. So let's use right here. If this is 76 degrees, what does that make this angle right here? Remember, consecutive angles are supplementary. So that would mean that this entire angle, this whole blue one, together, that would be 104 degrees. In fact, I'm going to do it over here. Opposite angles are congruent, so 104 degrees. So let's go ahead and start doing this. Oh, and if this is 104, that means that each of them are 52. So measurement of angle 1, 52. Do they ask us for angle 2? It's also going to be 52 because it's congruent. In fact, let's see if they ask us for these blue angles. Angle 6 and 7, yeah. 52. 52. Okay. What else do they ask us? 52, 52, 52, 52. Then they ask us angle 3. Well, we know that angle 3 is one of the red ones, and all the red ones are 38. So 3 is 38. 4. So everything that's in red, angle 4, angle 5, 38. Like all those red ones. 38. 38. By the way, this one should have had 2 curves. Because otherwise you're going to think it's congruent to this red one. Okay, 38, 38. And then measurement of angle 8. That's this one right here. Well, some of you guys might do the math. 180 minus the sum of 52 and 32. No, excuse me. This one right here, angle 5 is 38. So the sum of 38 and and then what do you have here? And 52. So that gives you 180 minus and then 90. Minus 90 equals 90. Or you could just remember that these are perpendicular. Okay. The diagonals are perpendicular. So if they're perpendicular, that means that those angles are each 90 degrees. Now I want you guys to try number 5 on your own. $52, you don't, okay, 52. How did I get 52? So remember that consecutive angles on a parallelogram are supplementary. They add up to 180. So if you get this whole angle, this entire blue thing, and this entire red thing, they will add up to 180. And we know that that together this is 76. Like right here, they tell us that this is 38. These are congruent, and these are opposite angles, so they're also congruent, and they're being bisected. The diagonals of a rhombus bisect the opposite angles. So these two are congruent, these two are congruent. If this is 38, this is 38. And because it's congruent to over here, 38, 38. Add them up, they give you 76. So this angle is 76, this angle is 76. So consecutive angles are supplementary. So if this is 76, that means that this one has to be 104, because 180 minus 76 gives you 104. And because these two angles, this angle is being bisected, therefore and together they make 104, and they're congruent, they are each 52. And because these are congruent, they're also 52. Mm-hmm. All right. So, all right, let's go ahead and do number 5. You guys do that one on your own. Yeah. All right, glad I could help. Yeah, definitely. If you guys need help, ask. I'd rather you ask me right now than when you're doing a test. Because if you ask me during the test, I'm going to be like, I don't know anything. I will suddenly have forgotten all mathematics. That's the only time I'm allowed to forget, when I'm testing you guys. Oh, I don't know. I'll give you 2 more minutes. Is there anyone who is lost? If you are lost, please tell me. All right. You guys ready to try this one? Let's go ahead. Who would like to tell me? Let's start off with just the segments, the lengths, not the degrees. So let's talk about these lengths. What did you guys get over here? You guys don't have to, and again, we don't have to go in order. So I'm guessing WZ is what you're saying is 34. Okay, where's WZ? Yeah. Well, if all the sides are congruent, so WZ is 34 because ZY is 34. So yeah, 34. WZ, ZY. Okay, what about VY? $19. Where's VY? Yeah, because WY is 38, therefore, and V is the midpoint, so VY has to be half of it. Very good. What about ZV? $28.2. Very good. Why? Because it says right here that XV is 28.2, so and ZV is congruent to that. What about ZX? Where's ZX? Oh, okay. Very good, 56.4. All right. Virtual high five for those of you. Got this. Okay. Now the angles. Dun dun dun. The angles always get you. All right. Well, with practice, but you do pretty good. I mean, you're not. I mean, you just maybe miss little details. But let's go ahead. So because you said that they get you, I'm gonna give you a chance to get them. All right. So what's WXZ? So where is WXZ? WXZ right here. Well, they tell us that use what they give you. So ZXY is 34. So what can we do with that? ZXY. ZXY is this one right here. And this one's 34, and they're asking you for WXZ. Michael, yeah, you got it. It's 34. Why is it 34? Because this is congruent to this. Remember, the diagonals bisect. And if ZXY, if this one is 34, therefore this one has also got to be 34. Okay. See, you had it right, and you were doubting yourself. You shouldn't do that. When you doubt yourself, bad things can happen. Yes. You need to be more confident. All right. What about WVZ? Where's WVZ? Oh, that's this one right here. $90. Yes. Why? Diagonals are perpendicular. Usually in these, you should always check to always see if they're asking for any of these angles right here. If they do, immediately say 90 on a rhombus, okay? If you do that on any parallelogram, you might get it wrong. If you do it on any parallelogram, you better hope that it's a rhombus or a square. But that's a bit of a spoiler. What about ZYW? ZYW, that's over here. You say 34? No, it's not 34. 56. It is 56 because remember, if this is 34 and this is 34, together they make 68. Okay. So 68 plus x equals 180. Subtract x from both sides, or you could just say, actually, let's, oops, 180 minus 68. The 68 is because these two angles together, these two angles are 34, together they're 68. So this equals 112. That means that these two angles right here, this entire angle is 112. But it's being bisected, so each of them is half of 112, which is 56 degrees. So ZYW, 56 degrees. And what about XYW? XYW, also 56, yeah. These are good. All right, now let's, you guys ready? Because now we're gonna do the most difficult one. All right, here we go. The properties of squares. I know. A square has all the properties of a parallelogram, rectangle, and rhombus. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. You have 4 right angles, diagonals are congruent, 4 congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. All right, so here we go. Let's get to this. Let's get to this. If ABCD is a square and AD is 11, find each missing value. So what is BC? Well, BC has to be, is BC a side? And AD is a side. So if this side is 11, therefore this side also has to be 11. In fact, all of these sides are 11. AC. In fact, let's go ahead and, this is congruent to this. And we can also do this. You see, there we go. In fact, I didn't have to do 3 dashes here. I could have just done 2, but whatever. All right. What about AC? What is the length of AC? Where is AC? Right here to here. Well, 7, if this 7.8, and therefore this is also 7.8. So add them together, that gives us 15.6. Very good. What about BD? BD is 15.6 again. Yeah. What about EC? Yeah. What about angle DAB or angle DAB? DAB. If you guys are doing the DAB, that's really cool. What's angle DAB? $11. Hannah, where did you get 11 from? Angle DAB. Angle DAB is This right here. Christopher has it. Yes, it's 90. AEB. In fact, this one I was supposed to be modeling for you guys, but you guys are kind of doing this on your own. Man, you guys are doing my job for me here. What's AEB? Okay, and I've lost. Okay, so you guys are saying your AEB is this one right here. Michael, did you? Oh, so Nicole and Michael, did you? You're saying 90. Are you saying 90 for this one, or are you saying 90 for this one? So for DAB, it is 90. Remember, all the corners are all 90 degrees in the inside of the square. They're all 90 degrees. What about AEB? This one right here. I actually use purple for this to label. This one, well, it's also 90 because remember the diagonals are perpendicular. Then we've got CBD. CBD. That's this one right here. Well, if all of this is 90 and it's being bisected because BD is bisecting that angle, therefore two angles together make 90, therefore they're each 45. BAC, where's BAC? BAC, this angle right here. Well, same thing. If all of this is 90 and it's bisected, therefore the two angles that are forming it are congruent, therefore 45. Christopher, this right here is 90 degrees. And that angle is being bisected by the diagonal. So you have two angles. So this angle and this angle are congruent, and they are together forming 90 degrees. So if two congruent angles form a 90-degree angle, they are each 45. Okay, now I want you guys to try number 7 on your own. And we will be done. In fact, and I said that part as a joke of the squares being difficult. I think the square is the easiest. So let's go ahead and try this one. I'm gonna give you guys till 52, I think. Shouldn't take you too long. See how many seconds you have left until it's 52. Yeah, I'll give you guys till 11:52, and then we'll go over this. All right, it's 52. All right, fun. Let's use a blue. Let's use purple for this. I was gonna use a pink one, but I'll save that for tomorrow. All right. So PQRS is a square and TR is 17. Find each missing value. All right, what's PR? . 34, very good. Yeah. Yeah, because from P to T, oh no. We remember that these are congruent. And if one of them is 17, that means add two of them together. So PR, 34. What about QS? Yes, it's also 34. I see you put 34 twice, therefore you were answering these two. So yeah, 34. If PR is 24, excuse me, 34, then QS is also 34. What about QT? Find QT. 17. Yes. Like I said, these are all congruent. And if one of them is 17, they're all 17. PQ. 24, yes. Why? Well, if PS is 24, therefore, and PS is a side, that means each of the sides are 24. PQ is a side, 24. All right, what about PRS, angle PRS? That's this one right here. $45, yes, good job, Michael. 45 degrees. What about STR? 90 degrees, yes. Why? Because it's where you have the diagonals crossing. Diagonals are perpendicular, so those angles formed by the crossing of the diagonals will be 90 degrees. What about PSR? Yes, 90 degrees as well. Woo! What were you confused on? Oh, makes sense? Okay, okay. And then what about QPR? 45, yes. Because the diagonal bisects this angle, the entire thing. QPS is being bisected by PR, by the diagonal PR. So therefore QPR and SPR, each of them 45 degrees. Congruent. Together they form 90. They're each 45. Let's see if I have it. Girl is on fire. You guys are on fire. Good job. All right. Which of this was the most difficult? And which of it was the easiest for you? And yes, I did have that picture ready because I knew you guys were going to do good. I had it ready to show. Oh, it's pretty easy. The degree part. Okay. Degree. The first part was the rhombi and the square easiest. I think the rhombi is kind of the somewhat of the most difficult one. First one, not so bad. The easiest part was the square, and the most difficult. The easiest was the square. The rhombi was the most difficult. Angles get you. The bottom of the first section. So the bottom of when we were doing the square, the rectangles. Okay, Ashley, you put the degree. The degree part for what? For which shape? Or all of it in general? All of it? Okay. You're gonna have to come to office hours if you're having difficulties. Okay, come to office hours and we'll help. We'll give you some additional help. Okay. You guys have a digital copy of your textbook. on, I think you guys get it through Power School, the big ideas. Open the book. You got to read it, okay? It really will help you. That's what I've said. Read your book. Look at your notes. Practice the problems, and you will get this, okay? Do you guys have a test this week? I'm not sure just yet. Okay.
I don't think they'll have a test, but a quiz sounds like a great idea.
Mhm.
Hmm.
You guys will be fine. Just practice it, okay? Practice this, and it shouldn't be too bad. Remember, prior knowledge still applies. What you have learned up to today, you're not allowed to forget it. Triangles add up to 180 degrees. You cannot forget that. That will always have to stay with you. Always, always, always. And something I like to do a lot of times is I like to draw on the, and as you guys were able to see when I was doing this one, you guys saw how I immediately look at number 3, or number 4. Yeah, 3 is the one I did for you guys. 4 is the one that you guys did. I started drawing things. I immediately figured out what each angle measures. So if you guys have a shape and you can do that, immediately do that. Okay. If you guys don't have any questions, oh, you guys have an assignment on your assignment on big ideas. Okay. So we'll go ahead and work on that. If you guys have no questions, we can go. You guys are free to go. Okay, but I'm still gonna be here and maybe for like 2 minutes afterwards. Okay. All right, you guys have a good one, and I'll see you tomorrow or on office hours.
Have
I
a good day,
just-
you guys.
I just realized last lecture when we were doing remember that one number 6 where it was the difficult one and there was the catch? I should have saved the picture. You remember did you ever see the Muppets movie from 2011?
No.
No, there's a scene where these guys are like, they're evil characters and this guy is talking. And instead of doing an evil laugh, he literally says maniacal laugh, maniacal laugh. And he's telling like his friends there, maniacal laugh. And so I should have showed that video when
There you go.
like, oh, is this the difficult? Like, where's the difficult? Like, is there a catch to this? And I just show the video. Maniacal laugh. Maniacal laugh.
There you go.
All right. All right, you guys have a good one. Thank you. All right, I'm gonna stop recording now.